Okay, so 5 stars for overall attendance. Thank you. So I will do my best to show you, especially as we're going forward, sort of the techniques to solve the problems we're working on. And that's kind of where the learning will be for the most part. We'll just learn different ways to use the NumWorks calculator. It's going to give us a lot of things as we work through the questions. But the quicker I can get through the lecture part gives you more time to work on the homework part and move forward. And that's really where the learning occurs. If you just go to the lectures or just listen to the lectures, you learn a little, but when you actually start doing the problems, that's where it all makes sense. So today we're the 22nd, so we're going to start into chapter 6. What this means is you should be a good portion of the way through chapter 5. Again, there are no hard due dates except when the test comes. You should have it all learned, right? But even then, you could go back and make it up if all you're concerned about is points. But what the homework really is there for you is for you to help you to learn the concept. So we're going to look at chapter 6 this week. We probably will have about an extra day or at least a half day in here. Then next week, we're going to get into review and practice test. And then we'll see what ends up working to be the best day for the test. But again, it'll be about a 15-question test, about 5 questions from each of the 3 chapters, 4, 5, and 6, much like we did last time. You still get a page of notes, front and back of a page of paper. So as you're doing the homework, anything that you keep sort of forgetting or having to go back and look up, that's the thing that needs to be in your notes. And if you put it in your notes and leave it while you're doing your homework, you'll look at it and then you'll just sort of remember it. If you try to memorize, at least me, if I try to memorize stuff, it's really hard and I keep forgetting. If I don't really try, I just set it on the side and I just glance, oh yeah, that, oh that. It will eventually pick up. Okay, so that's where we're at. You should, if you go to the grades here in Canvas, this is just a test student. I haven't been doing my homework, have I? But you should see something like this. And hopefully you've got some points in here, chapter 1, and you'll see there is the homework and there's the homework learning quiz. Let me close this down. Okay, so for each one it's there. Again, if you don't have it to 100%, what do you need? What could you do to get it to 100%? Well, you could do the extra credit, but just work that problem until you get it to 90. And then I will go in and manually change it to 100%. If you're satisfied where you're at, that's okay too. I've had some classes I just wanted to get through and get a C in, and some of my professors were saying, "Oh, I'll give you a chance to redo it." I don't want to redo it. I'm satisfied with the C. I'm not shooting for an A. That's okay. Okay. Some classes you're going to choose to do that. But anyway, you can look through here. We'll have through chapter 6 for this next test. But yes, there is also that extra credit. Now, there's actually 2 extra credits. When I go update grades, I'll kind of do that. There is that chapter 2, if you went through the Excel, using Excel. Actually, it's Google Sheets, but that's fine. And the first, introduce yourself. If you've done both of those, you've got a total of 2% extra credit that gets added to your grade. Okay. So those are there. But check on it. And where should we be right now? Hopefully through chapter 5, or again, be nice if you had 100% on these so that we could just focus on chapter 6. But if you're not, keep working on it. In college, this is a 4-credit class, right? What does that mean as far as how much work is expected from you? It means you should be here in class every day, and it's actually an hour in college is only 50 minutes, so we have shorter hours. But notice our class time is 50 minutes, so you're putting in 4 hours a week. How much studying outside of class should you be doing? The formula says 8 hours, 2 hours for every hour in class. That's not just for this class, but that's for every generalized class. Now, yeah, so Each week, 8 plus 4, see what, that's 12 hours. So each time you're taking a 4-credit class, you should be expecting to be spending about 12 hours in it. Now, sometimes you get by with less, but if you're not being successful and you're only spending 6 hours, what do you need to do? Up the effort, right? The time effort. If you are putting in the 12 and it's not being successful, you might need a little bit more, or you might need to come to office hours, get some tutoring. Okay. So what I'm going to ask is, it's okay to talk with your neighbor if we're talking about the math content, okay, and getting them on. And I'll assume that that's what's going on. But if you're talking about something else, it's disturbing to me. It's disturbing to everyone else around. So let's just kind of focus and see what we can do in getting through this stuff. And again, you'll see that there's a little bit of a switch to the way the presentations are working from this day forward. Let me get out of here. How many of you have started into chapter 5, at least a little? I know some of you have actually already finished it, so that's great. Okay, good. Because what you're going to see is chapter 6 is like chapter 5, but it's continuous. The way we're going to use numworks, we're going to use a slightly different of the distributions, but it's going to be very, very similar as far as how the distribution tool works. Oops, sorry. It's not supposed to go there. So we're going to get into chapter 6. Notice it is actually already pre-recorded from spring. I'm going to click on this, which gets rid of the menu so that it can be larger sized. And actually, I'm going to reduce it a bit. This is an interactive slideshow, so when you click on this, what you're going to be able to do, if I get it set just right, let's see if I go a little bit big, there we go, is the presentation is right next to a working numworks calculator. Okay, so if you've got your computer up, what you should have on there is only one of two things. What's one of the things that you could have on your computer? What's that? numworks calculator. Okay, and again, we're all adults here. Actually, even if you're 17, you're still an adult because you're in an adult class. You're in college level. So numworks calculator, or you could have this up if you wanted to, because it's a presentation and it has the numworks calculator right there. What it's going to do is we're going to just work through some problems together, seeing how the calculator works, and boom, we're done. And these sort of these are homework type problems. So you're kind of getting right into the homework set. Okay. So we're going to start with what's called the standard normal distribution. Standard normal distribution. Tomorrow we'll do the normal distribution without the word standard. So when you see the word standard, what that indicates is it's telling you that we're dealing with a normal distribution. And does anyone remember what a normal distribution, what the graph looks like? I go like this, a bell. It's symmetric. So normal curves, normal distributions are symmetric. So that's a key part. And then it has a mean and a standard deviation. And when we have standard normal, the mean will always be equal to 0 because it's been standardized. And the standard deviation will always be equal to 1. So we're actually going to do 2 sections today, because what we do with the standard normal is very similar to what we do with the normal. All we do is change the mean and standard deviation. Okay. So far, so good. Oops. Okay. So when we go to use the NumWorks calculator, usually it starts off at calculator. What we're going to want to do is come down to distributions. Remember, this is why I had to update all the calculators. It was missing this particular app. And you're going to see that app will save you 5 to 10 minutes per homework problem. Save me 10 minutes, maybe you're 5, maybe you're faster than I am. But anyway, so we're going to go to distributions. We're going to go to the normal curve. So once we hit OK on distributions, remember we have all these choices. Chapter 5, we've been using the binomial, which is a discrete probability distribution. So the values were equal to 0, 1, 2, 3, 4, or 5 exactly, nothing in between. What we're doing today is the normal distribution, which is continuous, and so it can have all the values in between. Okay, so I'm going to go OK. And then, go over here, for the standard normal, so the first part of the homework, when it says standard normal, it means the mean is 0 and the standard deviation is 1. And that's the default. Okay, so we're set to do the standard normal. The thing is when we get to the next step where the mean and standard deviation are something else, we'll have to change them. And then if we come back to a standard normal, we have to go back and change it. And oftentimes students say, well, what's the mean and standard deviation? They didn't give it to me. When you see the word standard normal, they are giving you mean is 0, standard deviation is 1. Okay, so we'll work through it a few times, but okay. And then when we go to the next step, so 0 and 1, we just accept them as the defaults. We get the bell-shaped curve. And since it's symmetric, how much of the curve is below the mean? The mean is 0%, below 50%. Okay. Now let me introduce you to the tools in here. There's actually only 3. The part that's missing from the binomial is that it cannot be exactly equal to any measurement. Because it's continuous, think about to your geometry, how thick is a line in geometry? What's that? It doesn't have any thickness, right? Yeah, exactly. So that's why the probability of being exactly at a value is always going to be 0, because that's a line, a continuous line. A line actually has a 0 width. Okay. Now, when it's discrete, those are the values, but when it's not, it's the thickness of a line in abstract mathematics is 0. So, okay. But we will get used to, we have either below a value, we have between 2 values, and we have greater than a value. And all you have to do is look at the questions, which one are they asking for? We put that value in, and remember that's going to be a standard deviation, either above or below the mean. And what we're always going to get is the percentage of area under the curve, which is a probability. So the probability of being below the mean is 50%, okay, or 0.5. Seems simple? Good, because it is. But it can get confusing, okay? So the 3 different ones, we've got less than, between, and greater than. And as you select each of these, like if I go to the between, notice there's 2 values, and the x is in the middle, so it's 2 values on each side. And again, the question will be very obvious which one it's asking us for, okay? And then if we choose the greater than, we just come over here, we use the greater than, and you'll see x is greater than or equal to a number, and we get the other side, the greater than. That's all there is to this, okay? So these are going to give us our values, but the value of using the NumWorks is this is the only calculator I have found that actually gives you the graph of the area you're getting. And you're going to see how this is helpful. So while it will give you the answer, you're going to record that answer as your homework, the decimal or the percentage. I also want you looking at the graph to verify what it is. When I was learning this, we had to draw this on our own. We had to look up in a table. We didn't have calculators that would do this sort of stuff. And yes, it was horse and buggy day. No, it wasn't quite that old, but some days it felt that way. Uh, okay, so let's just get into doing a few questions. And what you're going to see is probably in the next 10 minutes, we're just going to go through a lot of different problems, and we're just using the same tool. That's pretty much the same in here. You get into the homework, there'll be a few concepts that you will, concept type questions, but we can work through those. Okay, so let's see, we've done that one. So yeah, this is kind of what I took you through. You can do between two values, so between 0 and 1. Here's it's 34.13. Remember when we did the empirical rule, we said between 0 and 1 standard deviations was 34%. We were just rounding, but now we can get exact values, okay, which is really cool. And then there's 34 below, so that's where that 68% comes through. But this is going to be a very valuable tool when we go on. And then greater than, just changing to that tool, so there's 50% of the data is above the mean. Okay, so here's a homework type question. Find the cumulative area to the left. Oops, sorry. I gave the answer before I asked the question, right? To the left, that corresponds to a z-score. So this is another piece of vocabulary I'm putting in. I'm not spending a lot of time. Before, we used to spend probably a whole week teaching you how to get a z-score, and I'll just give you 10 seconds of it. A z-score is this formula. You take the data value, you subtract the mean, and you divide by the standard deviation, okay? And that is how we standardized all calculations that we needed to do. And in the old days, we would use this formula, and then we'd get a z-value, and then we'd go look up in a table the percentage. And then sometimes we had to do another calculation because the table only gave us percent below. So to get percent between or percent above was always an extra calculation. Yes, sir. Oh, yeah. Heck, I would have got my doctorate by the time I was 15 if I had this stuff. Maybe not quite 15, but certainly by 25. But yeah, it took me 5 years to get through college because, yeah, we had to do it all by hand. And I didn't work that hard, really. Actually, I didn't even want to go to college, but Dad says you either go to college or you pay rent. I didn't want to pay rent, so I went to college. So that's just the honest truth. And then while I was in college, I found there was something I could do, and it was much better than digging ditches. My friend got me a job digging ditches, and I'm not a very muscular guy. I didn't like that one, so I went to college, so I didn't have to dig ditches and didn't have to pay rent. That was it. You guys have better motives, I'm sure, because believe it or not, I didn't even take math my senior year of high school. I had a problem with my math teacher, and as a junior, he was picking on me, whatever. At least that's what I thought. So I dropped that class and never went back to math because I never thought I'd need it again. And I'm not a math teacher because I love math. It's because I'm dyslexic. I almost dropped out of college because of math. And so I had a dyslexic professor, fortunately, who at the time I'm ready to drop out of school, he helped me to understand. I go, wow, now I understand math because he taught me how he saw it. Anyway, side story, but okay, z-scores. So when you see z-score, all it is it's a score of how many standard deviations away from the mean. Okay, so if we've got the standard normal, that's all we need. If it's positive, it's above the mean. If it's negative, it's below the mean. See, so simple. And so there's this extra question, will the area be more or less than 0.5? Let's see, we're going to the left and we're above the mean. I think so. So all I got to do to figure it out, though, is make sure I've got, see, the right tool. So I want the left then, that's to the left. And so see how this tool works? You could see it. Yeah, so if you're more visually oriented, it gives it to you. And as soon as you do that, if you're more symbolically oriented, you see that, to the left means left then. So it gives both of us a chance. And then all I've got to do, oops, I'm in the wrong place. Let me clear that out. All I need to do is put in the z-score of 1.15. Go, okay, here's 1.15, and here's all the area to the left. It's about 87%, 87.5 if you were to round it to one decimal place. And doesn't that look like about 85% of the bell, roughly? So you get those two things going on. You see the picture, you get your answer. So in the homework, you would either put in 0.875 or you'd put in 87.5%, depending upon which way it wanted the answer done. We're done. Again, in the old days, we would have probably been given some values. We would have had to find the standard score. We would have had to look that up in a table, and then we would have had to enter it in. And we might have had to draw this on our own. And so that's why we spent like 2 weeks just learning how to draw these little bells and fill them in to get an idea of where they're at. And notice what we're doing is we're flipping it on you. You're going to see the bell, but I want you to at least look at them so that that hits in your memory what that's going to be. And so you'll get a visual, so you'll be able to get the visual answer as you go. Okay. So the next question, find the area under the standard normal curve to the right of z equals 1.05. So to the right just means we come over here and we go to the other one, the last one, which is to the right, and we put in a standard score of 1.06, which, since it's positive, is it above or below the mean? It's above, and we're going to go to the right. So we would expect it to actually, in this case, be less than 50%. But you'll get, by doing this, you'll start seeing that and anticipating, and you'll kind of know when you got the right answer and when you maybe flipped and used the wrong tool. Because that's the kind of things that happen here. So I can see, yeah, there it is. And then in here, I give you the answer as well. And again, for this one, we're putting in 14.5% or 0.114 or 145 or 14.5%. Or if they want more decimal places, we do that. That's all, part of the game. But we just, boom, boom, we got our answer. This one, you would have looked it up in a table, and since the table always gives you less than, you would have had to subtract from 100% to get this one. So again, there's a couple extra steps if we use the old methods of just looking it up in a book. But we're in the world of technology now and apps, and this is where we're at. There's only one other thing we can do, and that's to find between two values. And again, this is maybe, I guess you could say, the hardest one, but I don't know if it's all that much harder. If we want the area under standard normal curve between these two values, what do? We come get the tool that is the between, which is the middle tool. Good place for the middle part to be, right? And we have to put in two values instead of just one. So we arrow over, put the smallest value first. So minus 1.5, which is below the mean. And then we put positive 1.25, which is above the mean. And that gives us our answer of 82.8%. Right? Again, depending upon what we need to round it to. So our answer is 0.828 or 82.8%. Okay? So not that much harder. Again, if we looked it up in the table, since it's below, we actually would have had to look up both of these values and then subtract them from each other, and then that gives us the middle part. And again, it's easy to mess up with that one because there's a lot of, again, it would take a whole week just to get you up and running on the table. We're going to get so instead of spending 2 weeks on this, we're really only spending 1, but that's because we've got this particular tool. Okay. So far, are we feeling comfortable? Awesome. Yes, question? No. Okay. So see, we're almost done. And what you're going to see, I'm going to go into the next section without, see, you're ready to do like the first part. Anything with a standard normal, you're ready. Anything that's not a standard normal, there's just one extra step. And then you're ready. Okay, so let's go through the extra step. This one, we know it's not standard normal. Why? Because they give us the mean is not 0, it's 81. Standard deviation is 5. It's not, no, sorry. Mean is supposed to be 0 and standard deviation 1. So we know this is not standardized, But that's okay. Again, in the old days, we would have standardized it with that Z formula, but we're not doing that. We're getting directly to our answer, and we're working with our data just as it is. So 81 is some measurement. I don't know, it's like 81 centimeters long is the mean, or whatever it is. It's the piece of data. So now this tool also allows us to work with the data just as it is without having to turn the mean into 0 and then maybe having to turn it back. Okay, find the probability that x is less than 76. Okay, so the only extra step we need to do is we just need to go back and tell our calculator that the mean is not 0, it's 81. And the standard deviation is not 1, it's 5. That's the only difference, okay? It's going to handle all the formulas for us. It's going to handle all the calculations for us. And now for us, it's just like what we were doing in the previous step. Less than 76, well, that's the less than, that's to the left. And I just put x is less than 76. What's that? Say that? The 81 and then the... Yeah, so that's, before I get here, if I go back, that's in this part of the calc. So that's the first step. When you come into the normal curve distribution, you enter the mean and standard deviation. So you'll get comfortable, hopefully, with going back and forth between these. And once we have this set in, that's what it's going to remember. And then we just put in 76. And we hit execute or OK. And you can see that's about 15%. I'm going to click this. So this, again, the nice thing about using this is you can click through here and it will give you the steps of the picture. So until you start to remember them yourself, here it is. So it's 15.9% or 0.0159 to 3 decimal places. If they want 4, give them 4, but you know, we got our answer and we can see, yeah, it's the bottom 15%, right? Now, the only thing I'll mention is this says less than 76. In our calculator, it says less than or equal to, right? But what did I say in a continuous distribution? What does equal to always mean? How much area is there in that equals to? How much width is there to a line? 0, right? So we're thinking back to our Euclidean geometry from probably 8th grade or something, but a line has no width. So less than and less than or equal to are going to give us the same values in the continuous distributions. Okay, so don't get too hung up on that. And again, just depending upon how they want the answer, 15.9% or something like that. So again, just make sure you're rounding it to the right decimal places. Got to read all the fine print. Sometimes I skip over that, but if you're getting it wrong, check your decimal places. Also check whether they want a percentage or whether they want it as a decimal. Okay, so those are 2 easy mistakes to make, reasons to get them wrong, but remember you get multiple tries, so just take a quick look. Oh, they wanted a percentage and I gave them a decimal, or vice versa. So far so good? Only 2 more things, right? And then you're just experts at the next section. That's what I love about using this. It's nothing really much extra to teach you, right? The probability that x is greater than 43. And again, notice with each of these questions, you're going to have a different mean and a different standard deviation because you're dealing with some different data. But these are actual measurements of the data, right? 50 inches or something is the average. So we come over here. All we have to do, what's the first thing we have to do? We have to change our mean and standard deviation to match what we were given. Sometimes I'll forget to do that, and then the answer is meaningless, right? Because you don't have the right stuff in here. And then we just want greater than, so we go down to the greater than tool, and then we change x greater than what? X greater than 43. Now, you can anticipate 43 is less than 50, right? So that's actually below the mean. And so when we get it, we should see something like this, right? And hopefully that as you look at those pictures, it will either validate something or remind you of something of this property. Okay, so spend that extra 5 seconds to look at that graph and see how it corresponds to what you're doing. Okay, that's why we do this. We're saving, remember, you're saving 5 to 10 minutes easily on each question. So they'll take you like 30 seconds to get done, but don't rush it. Spend an extra 15 seconds to at least look at the graph and say, oh, that graph, it matches. Okay, it's a little bit below the mean and we're getting above the mean. Okay, again, change the deals and there. One last thing, and then we're pretty much done. I think there might be an extra thing we've got in here, but yeah, so this is going to do all three. So we can do less than a number, between two numbers, or more than a number, but this has a little bit more meaning. So we get a monthly utility bills in the city are normally distributed. So that's usually what it'll state, because if it's not normally distributed, we can't use this tool. So just think it's not a big deal, but it's telling us, hey, you can use the normal distribution tool. It's got a mean of $100 a month and a standard deviation of 15. So what does that mean? On average, people are paying $100 a month for their electricity, plus or minus 15 is one standard deviation. So to answer these questions, what's the first thing we do? Excellent. Change our mean and standard deviation. Let our calculator know what's going on. Pretty soon we'll get where they just take a picture of it and the calculator will do it. Actually, they probably got stuff that already does that, right? But I think it's called, anyway, it's got a name, 15, but a little bit of steps. And now notice, though, we're working with data $67. What's the percent of people who have a bill less than $67? Again, we come to the less than tool, and then we enter here, X is less than or equal to $67. We'll hit OK, and there's this little shading here. It's way in the corner. And I'll give the bigger picture here, right? 60 less than 67. That's 0.0139, less, 1%, 1.4% if you want to round it to a decimal place, right? 0.0139, or not 13.9, 1.39%. And while we're here, we don't have to do too much more, but to get between 88 and 120, we just go get that tool, the between tool, and we enter exactly 88 and 120. And we get our shading, and we can kind of see where it is. And notice the scale at the bottom is even in these values, right? It's in what we're working on. Let's come here. Take out the writing. Okay, and so that's 69%, 69.7% if you round it. Okay, or if they want it as decimals, you put it. So you've got your answer, but then look at this. Oh yeah, that's over the mean. Here's, and you can even see here's 120, 88 to 120. So you get to see it. And then finally, more than 130. Again, you could go, you go to the tool that's above. Okay, and you put in 130. And it's way up here. So it's not very likely to have a, if you're on average, it's not very likely to have a bill of 130, which is a good thing, but it's also not very likely to have a bill less than $67. So this electricity is expensive. In fact, actually, this is probably multiplied by 3. Do you realize your electricity here in California, I moved from Phoenix, it's 3 times the cost of Phoenix. And Phoenix isn't cheap. Oregon's really cheap because they use hydroelectric power, but anyway, kind of, yeah, it got me. I used about what usually costs, because when I first came, it was January, so I was using my space heaters, and it usually would have cost me maybe about $100 a month. It cost me $300 that first month, and I go, dang, I can't live like this anymore. I got to wear jackets in the house. So, okay, so we good? Let's see. Here's another one. Again, we can do these. What is the percent of scores less than 19? They give us the mean and the standard deviation here. Look, we can work with things with decimals, even that, they're not pretty numbers to work with, but this handles it all. and we don't have to worry about going into the charts and trying to find things and how to draw it. So it should, notice it looks very much like this. Here's 19, here's 21% of the scores that are less than 19. We just come here, yeah, we're already at less than. So we put in 19 and we match this pretty good. And it shows, and we just do that, about 41%, right? And then out of 50, now this is the one that you may see. Let me back up. Oh, I guess it's okay. This is one that may require calculation, but it takes us back. Out of 1,500 randomly selected scores, about how many would be expected to be greater than 21? Okay, so first we come over here and we find the percentage that are going to be greater than 21. Come here, put in our 21, and we've got a percentage, right? 44%. What do we do with that percentage? Awesome. So you guys are already experts. So that's the one. Sometimes you're going to have to do this calculation, but it's just we're getting a percentage probability. We multiply it by the number we were given, the 1,500. Come on. So we take our 1,500, multiply it by 0.4411. Use as many decimal places as you need. Well, wait, this calculator doesn't work anymore. Yes, it does. We go back to the main menu and we go back to the regular calculator. So we got this and we can take the 1,500. It'd be nice if it did it right in the app, but it doesn't, I don't think. And then we see that that's, what is that number? Oh, I didn't put in my decimal. It should be about 600. So let's try that again. 1,500 times 0.4411, 600, and maybe round up because it's probably, it's people, I guess, or randomly selected. It's a score, so you either have 681 or you have 682. Let's round it up to 682. Okay. So that's pretty much like the only calculations you're going to need to do. Seem good? All right, let's see if there's any more slides left. There are not, so that means we're done with the first two sections of chapter 6. There's a little bit of time, I understand, if you want to just kind of chill, and because there's a lot that it's in there, but tomorrow you'll have the whole time to work through chapter 6. Okay.